answers to quiz 2. Ready, Taylor? And what I'll try and do is also, because what I hear people saying time and time again, you know, Mr. Dueck, once I have the setup, then it all falls into place. The tricky part is knowing the approach. I will try to narrate out loud how my brain approaches these. So number 1 says this: when you toss a fair die 3 times, what is the probability that you would get a 5 on the first toss, a 6? You know what? Comma in English does mean and. So I'm already thinking probably that. And there's definitely an and there. These are dice questions. You'll notice I've never given you any way to handle them except to count, because there's only 6 outcomes. So what is the probability you'll get a 5 on the first toss and a 6 on the second toss? Any number except a 2. Oh, what's any number except a 2? Right? I used the complement. I said, well, a 2 is 1 out of 6, so not a 2 must be 5 out of 6. It's going to be top times top times top over bottom times bottom times bottom. It's that. If you change it to a decimal, I have no idea what that is, but 1 mark for that. Okay. Number 2. Grayson, can you read to me question 2? Stop. I kid you not. As soon as I see that ding, 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 I'm going, probably a tree, 2 cards. 1 card I'll count and maybe use a formula like or means add minus the overlap. But 2 cards, I'm going to tree. Keep reading.
Are drawn from a well-shuffled deck of 52 cards. What is the probability that the first card is a heart and the second card is a heart?
Okay. What's the first event? That. Heart on the first, right? And then the second event, now I'm being really lazy here. I'm not drawing the whole tree. And the only reason, Alyssa, that I'm daring to be that lazy is it's the same event twice in a row. That I can keep track of. That I can keep track of. Oh, are we replacing the cards or not? Okay, because that would make a difference too. How many hearts are there in the deck? And this, you've got to, by this time, have a little bit memorized. 13 out of what, Jake? Okay. Now, if I was replacing, if this was with replacement, then my next branch would also be 13 out of 52, but it isn't. It's without replacement. So I got a heart. Happy Valentine's Day. How many hearts are left in the deck? I didn't get a heart at all. Matt got a heart. Oh, 12 out of 51. Now, multiply. It's going to be 13 out of 52 and 12 out of 51. It's going to be 13 out of 52 and 12 out of 51. Do you get 1 out of 17? 1 mark. So what was my strategy? What approach did I use here? Tree. How did I know to use a tree? 2 cards. 2 cards. Okay. Good, because I need these anyways. Suppose is the first word I see here. You know what? That's another word for conditional. And that's confirmed when I see that there. Can you read, Oscar, the last sentence? Now, how many dice here in this question? How many dice? 2. Okay, I could do a tree, but don't write this down. It would be this: 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 1, 2, 3. I'd have 6. Ugh. So for 2 dice, and I will ask you 2 dice on your test. A sample space. And here's what I mean by a sample space, which is why I left you lots of room. I'm going to have, let's see. I see there's a black die and a white die. So I'm going to go 1, 2, 3, 4, 5, 6. And I'll go 1, 2, 3, 4, 5, 6. And so here, I'm going to have a 1 and a 1, a 1 and a 2, a 1 and a 3, a 1 and a 4, a 1 and a 5, a 1 and a 6. Hang on a second. Let me pause the video here. Okay, and I'm just going to, it takes about 20 seconds to fill one of these out, but it's worth the 20-second investment. This is going to be 2, 1, 2, 2, 2, 3. I'm going to stop calling them out because I can't write and do this at this. 3, 1. 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6, 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6, 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. Now, I did see somebody, I can't remember who I was talking to, and instead of listing both dice, they actually just did the totals. In other words, they went 2, 3, 4, 5, 6, 7. Here they had a 9. Here they had a 9. Here they had an 8. I guess. What do they want me to find? Well, black is 2. That's that whole row there. That whole column there. Adds to 8. Total is 8. That is, hello. This, 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 this. Yes? So, this is conditional. This is going to be both over the given one. Black is 2. That's 1, 2, 3, 4, 5. You know what? 6 out of 36 possibilities are where the black die was a 2. How many are both add to 8 and black was a 2? How many are circled twice? 1 out of 36. This is same strategy I've been using, Brianna. Both and over the given one. Which one is both? The one that's been circled by both. Which is the given one? Black, which I conveniently circled in black because I had colors like that. 1 out of 36 divided by 6 out of 36. The answer is 1 out of 6. And now that I see that, Darian, I see a more intuitive way to do it. I say, oh, you know what? There are 6 that are black. Only one of those 6 adds to 8. Now I can see where that 1 out of 6 comes from. But my conditional formula worked. That's my point. Is that okay? You know what I'm going to do? Because I need a little bit more room for number 4. Cleverly, I'm going to go like this. And I'm just going to slide the whole thing up about that much. I'll just have to delete that. There we go. Number 5. Ready, Grayson? This is going to be your cue again. Can you read to me, please? Stop. How many people? How many cards? 5. How many, whatever. You know what? For 5 things, Grayson, I'm not going to use a tree. I'm going to use a bucket. Now, I said that at the end of the question, but I'm telling you how I would know to use a bucket. Okay? So my bucket is going to have groups. It looks like my groups are boys and girls. Before we start picking, how many boys are there in the deck of cards grand total? And I'm phrasing it that way to also relate it to card questions. How many boys are there grand total? 4. How many girls are there grand total? How many boys do we want to choose, Grayson, my joy? How many girls? Now, you'll notice I only told you how many girls. I made you subtract to find the boys. I think that's totally fair game, yes? As an equation, then, it's going to be this. 4 boys, choose 2, and 5 girls, choose 3. That's how many ways that you can pick 2 boys and 3 girls. To turn it into a probability, we divide it by the number of ways that you can pick from 9 people, 5 people. Also, Pam, you recall there's a built-in error check. Front plus front equals front, back plus back equals back. This is going to be 4, choose 2, and 5, choose 3, divided by 9, choose 5. I'll take, because some of you don't, your fraction button doesn't work. If you said 0.462 or 0.48 or whatever, I'd take that. I'm going to write it as a fraction because I can. Try that again, Mr. Dueck. Really? Hit the wrong button. Let's do that. 10 out of 21, is that right? Or 0.476. Okay. Turn the page. Here's your cue again, Grayson. Start reading, please. Stop. How many dart players? I'm right now already leaning towards a tree, but now I'll keep reading. Each throw independent. Now, what independently means is the odds aren't going to change whether they hit or miss. That's easier, I think. The probability of each player hitting a bullseye is 0.3 and 0.4 respectively. What's the probability that at least one of them will hit the bullseye? You know what? Let's call the players player 1 and player 2. So it seems to me they don't shoot at the same time. I've watched darts. Let's have player 1, Brianna, go first. Okay? Bullseye for player 1. Not bullseye for player 1. According to this question, Brianna, my joy, what's the probability that player 1 hits a bullseye? .3. Now, this is not in the question. I have to use the complement. What's the probability that he misses the bullseye? It's not in the question. I have to use the complement. What's the probability he misses the bullseye, folks? 0.7. Okay? And remember, Brie, we have a built-in error check. Do those add to 1? Check. Now the second guy goes. I'll call him a bullseye from player 2. He can hit, or he can miss. Down the other branch, he can hit, or he can miss. What's the probability, Brianna, that the second guy hits a bullseye? Not 0.3, the other one. 0.4, that's what respectively means in that order. What's the probability he misses? Yeah, careful, complement. Not 0.7, that was the top guy. What's the complement of 0.4? I think 1 minus 0.6. 0.4, 0.6. Grayson, remember the word independent? Here's how I can tell it's also independent, because these 2 branches match those 2 branches. Apparently, whether the second guy hits a bullseye or not, it's not affected by whether the first guy hits or not. And you can argue whether that's true in real life or not. You might say, oh, in real life, if the first guy hits the bullseye, there's more pressure. I don't want to get into sports psychology. I'm just making up a question. Bree, can you read the last sentence to me, please, dear?
What is the probability of
At least one. So let's walk down each branch. I'm going to put a check mark underneath it if it qualifies for at least one. Down this branch here, did at least one hit the bullseye? Down this branch here, did at least one hit a bullseye? I see someone shake their head and I see someone nod their head. Oh yeah, because first guy did, right? Down this branch here, did at least one hit a bullseye? What about down this branch? Okay. So multiply down, add across. One way to do this would be to go. Sorry, let's try this again. 0.4, 0.3, or 0.3, 0.6, or 0.7, 0.4. Anybody see a faster way to get there? Complement. You could go One takeaway, they both miss. That'll also get you there. I'm going to choose to do that one because I can do it in my head. I know 0.7 times 0.6 is 0.42. 1 minus 0.42, is the answer 0.58? Or 58%? Or whatever that is as a fraction, I don't care. They gave it to me as decimals, I'll give them the answers as decimals. Okay. All of these have been worth 1 mark. The fact that number 6 is worth 2 suggests a little tougher. What's my strategy here, Mac? Tree, because I said so. Well, also because there's 2 events. Pick a bag, pick a marble. This goes, again, to what I've been picking on Grayson for all class. If there's 2 events, I'm going to fall back on a tree. This, by the way, is why I restarted the probability unit. I felt I was missing out on giving you this very useful tool. I was going to say trick, tool. So far, so good. So, Taylor, I got to pick a bag. Then I got to pick a marble. I'm going to draw a tree. Bag A, bag B. Oh, this is interesting. A marble is randomly chosen from bag A and placed in bag B. A marble is then chosen from bag B. You know what? Bag A, bag B is not how I want to set this up. I think how I want to set, this is tough, how I want to set this up is first marble, second marble. What are my options? Well, for the first marble, I can be red or white, because it says I'm picking from bag A. What's the probability that I'm red? Okay, and you know what, Rachel, to show this is the first marble, I'll even put a little 1 there. Then, second marble can be, wow, red or white, red or white. Wow, I'm actually crying here. It's because of the Valentine, not because I'm coughing so much. Okay. Wow, here we go. Down this branch, we got a red marble. This cough candy is not kicking in here. Down this branch, we got a red marble. So we put that red marble into bag 2. How many into bag B? How many red marbles did bag B have originally? 2. How many does it have now? 3 out of 4. I can do the math for the other one. It's got to be 1 out of 4. Down this branch, we got a white marble, and we put it into bag B. So how many white marbles does bag B now have? 2 out of 4, because we added a marble. And that must mean that. There's my setup. Jake, what's this question want me to find?
Probability of the marble selected from bag B's.
This branch or that branch? One-third times 1/4, or 2/3 times 2/4. I think you get 5 out of 12. Now, I made this 2 marks. I would give you 1 mark for the tree and 1 mark for the answer. And I'm willing to bet that one there seemed very tough, and I'm willing to bet most of you got it wrong. But do you see, Darian, we can handle it with the skill that we have. We can be careful. We can handle it. Turn the page. Okay, now we're picking a jar and then picking a marble. Now we're picking a jar and then picking a marble. Going to use a tree. So it's going to be jar 1, jar 2. Is it a 50-50 chance that I pick jar 1? No, it says we're going to roll a die, and if a 1 or a 2 comes up, we're going to pick jar 1. So 2 out of 6, 4 out of 6. Yes, Darian, you could also put 1 out of 3, 2 out of 3, but I don't like to reduce. Then it looks like jar 1 has red, white, and black. And it looks like jar 2 also has red, white, and black. But in jar 1, it's 3 red out of 10, 2 white out of 10, 5 black out of 10. In jar 2, it's 4 out of 12, 5 out of 12, and 3 out of 12. Sterling, what's part A want me to find, my friend? Here or here. Multiply down, add across. 2 out of 6 and 3 out of 10, or 4 out of 6 and 4 out of 12. It's going to be 2 fraction 6 and 3 fraction 10 plus 4 fraction 6 and 4 fraction 12. Do you get 29 out of 90? I would give you, in this question, 1 mark for the tree and 1 mark for the answer. If you got it right, get 2 out of 2. Darian, once you're done stretching, can you read me the first part of part B, please? Stop. What? Given, probably a conditional. Let me see. What did they give me, Darian? Bottom row. What are they asking me to find? Top row. This is conditional. It's going to be given red, find J1. I don't know what notation you use, but that's what it is in my notation, which is going to be both over the given one. That's how I translate the formula that is on your formulas page for this unit. Darian, what did they give me? Conveniently, that's what I found in part A. In part A, I found red. So I'm not going to redo it. I'm going to say, I know what the bottom of this fraction is. It's 29 out of 90. The top is the branch that's jar 1 and red. 2 out of 6 and 3 out of 10. Now, look up, please. If you got A wrong, but you dropped down whatever answer you got for A and you put it in the bottom of this second fraction, you can still get full marks for part B. As an answer on my calculator, I'm going to get, on the top, 2 fraction 6 and 3 fraction 10 divided by, I'm going to use my answer button because I have it stored. Do you get 9 out of 29? Or for those of you that have decimals, 0.31. And I will take decimal answers on the test or fraction answers, I don't care which. In terms of part marks, if somewhere I saw that you had written this, I would give you a half. First of all, if you got the right answer, 2 out of 2. I'd give you a half mark if I saw that. I'd give you a half mark if somewhere I saw that you translated it correctly. Half mark for that. Half mark for the answer. Keep going? Let's keep going. If each one of the 19 equally likely outcomes in sample space is S is randomly selected, find the probability that A and B occurs. You know what? I think we're only picking once. I can count it to solve it, Ashley. Nothing fancy. 2 out of 19. Right? A and not B occurs. You know, that's this. Isn't it? 4 out of 19. Neither. Oh, that's this. 8 out of 19. At least one of A or B occurs. By the way, that really just means or, because or means one or the other or both. 11 out of 19. You'll notice I didn't count it. I subtracted. Neither was 8, so I said 11 must be at least one. At most, one of A or B occurs. At most means this one or this one, but not that, because that's both. 9. Or is that a German saying no? 9 out of 19. A occurs given that, conditional, which is going to be A and B over B. 2 out of 19 over 7 out of 19. 2 out of 7. 0.41 or whatever that is a decimal. No, it's less than that. B occurs given that A has, that's going to be given A, find B, which is again going to be both A and B, or you could write B and A, but it's going to be over A. It's going to be both 2 over 19 over 1, 2, 3, 4, 5, 6. Which ends up being, I think, 2 out of 6 or 1/3. This is the power, Zach, of that conditional formula translated properly. Turn the page. Machine A produces 60% of a product. Machine B produces 40%. Hey, we've done one like this before. In fact, Rachel, I lifted this right from the lesson 5 homework and just changed the numbers. So we have this, machine A, machine B, and then it can be defective or not, defective or not. 0.6, 0.4, change the percents to decimals. 0.03, 0.97, 0.02, 0.98. By the way, be careful. 3% is not 0.3. 0.3 is 30%. 3% is 0.03. Defective, Taylor, this branch or this branch. 0.6, 0.03, or 0.4, 0.02. 0.6 times 0.03 or 0.4 times 0.02. And I get 0.026 or 2.6%. Anybody go fraction on that one? Okay. By the way, for this one, 1 mark for that, 1 mark for the tree, and then B is going to be worth 1 mark as well. Conditional. Given that it's defective, find machine B, which, Mac, I'm arguing is B and D over the given one, both over the given one. Conveniently, Matt, I just found the given one, D in part A. I know this is going to be 0.026. B and D is going to be 0.4 times 0.02. It's going to be that branch there. 0.4 times 0.02 divided by 0.026. And I get 0.308, 0.31. I don't think I said how many decimals to go to. I'll go 0.308. Okay. I would give you half mark if I saw that. Half mark for the answer. Turn the page. Oh, Brianna, I got you committing a crime later on here, don't I? First of all, disease. Suppose it's known that 2% of a population suffers from a disease. A test is 97% accurate. Okay. You have the disease or you don't. You have a 0.02% chance of having it, a 0.98% chance of not having it. Then you can test positive or negative, positive or negative. Darian, once you open your eyes, how accurate is this test? How accurate is this test? Say it again, nice and loud. So if you have the disease and the test is accurate, what should you test, positive or negative? Loudly, with authority in your voice. 0.97% of the time it'll catch it, 0.03% of the time it'll miss it. Now, if you don't have the disease, should you test positive or negative? With authority in your voice. So 97% of the time, on this branch, the negative one will show up 97% of the time because you don't have it. 3% of the time, you'll have a false positive. That's why I phrased it that way. Instead of breaking it down, I just told you how accurate the test was. With me so far? Okay. Darian, what's the given? Given what?
Given that the person tests positive.
Find what?
Find the probability that they're
There it is. And you know what that's going to be? Both over the given one. Both over the given one. D and P. Hey, that's that branch. The given one. Hey, that's this branch or this branch. They both end in positive tests. .02 times 0.97 divided by bracket 0.02 times 0.97 plus 0.98 times 0.03. Typos, Mr. Dueck? Looks right. You actually only have a 39.8% chance of having the disease. You got a better than even chance of not having it. 0.398. So if you got that, you get 3 out of 3. Otherwise, I would probably give you 1 mark for the tree. I think I would give you a half mark if I saw that, a half mark for the numbers, and then 1 mark for the answer. I'm fighting on with you, sister. Oh. Last one! Woohoo! You know what? You know what I'm going to do next year, Brianna? I'm going to get the Law and Order chung chung sound, and I'll play that next. I can find that somewhere because it should be Brianna has been accused of a crime. Chung chung. Right? Wouldn't that be great? Thing next year. And volunteers to take a polygraph test. Now, of course, we know Brianna is innocent. From previous studies, and they've done plenty of research into this, although I made this number up, I'm sure you could find these stats somewhere. If any of you ever go into the legal profession, please remember this. It's known that people tell the truth to the police 99% of the time. And the polygraph test has an accuracy of 95%. Brianna, you failed the polygraph test. Chung chung! what is the probability that you're actually lying? So our tree is going to look like this. You're either lying or not. Fail, pass, fail, pass. I could have gone fail, not fail, but I figured the pass will be easy to keep track of. Is that okay? What's, according to this question, since this is your life on the line, Brianna, I got to come back to you here. What's the probability you're telling the truth? How often do people tell the truth in this question? As a decimal 0.99. What's the probability that you're a liar? 1%, or as a decimal 0.01. Good. That's the complement trick. Okay. How accurate is this test, Brianna? So that means if you're lying, it should catch you. Here, you lied, you should fail. How often? 95% of the time. But you know what? Maybe George Costanza could pass the polygraph. You may have seen that Seinfeld episode. It's not a lie if you believe it. Right? Here, you're telling the truth, and we know you're in this branch. So if you're telling the truth, it should say that you're telling the truth. You should pass the test. Right? How often? 95% of the time, because that's what 95% accurate means. But you know what? You may be telling the truth, and it may think you're lying anyways. You okay with the tree setup? All right. Ready, Bree? Here we go. Given what? Given what, according to this question? So find the given. That goes there. Find what? Keep reading. You'll get it. Find the probability that what? There's our that's how we translate it. Figure out what's given. That goes after the little vertical bar. Now, and here's what I'm saying. This is going to be L and F, both over the given one. Always. L and F. Bree, that's that one there. 0.01 times 0.95. F, well, that's this branch or this branch. 0.01, 0.95, or 0.99, 0.05. Boy, I think I've weathered that coughing spell. I feel way better now. That was ugly for a bit there. I really was crying. Oh. 0.01 times 0.95 divided by... Brianna, is there more than one number in the denominator separated by a plus sign? Say yes. So you know what I got to do with the bottom? Put it in. Help me out, folks. Put it in. Brackets. Dunk. 0.01 times 0.95 or 0.99 times 0.05, close bracket. Is she lying? Chung chung. Probability that she's lying is only 0.16. Which means there's actually an 84% chance, Brianna, that you're telling the truth and you're going to be falsely accused. And dead honest, because I suspect since the events in Parliament, Canada is going to become similar to the US. We're going to become more paranoid because we did have our first terrorist attack. If you're ever told that you need to take a polygraph, get a good attorney. They're people who are running them don't understand this. Don't understand this. Can you give yourself a score? Oh, you know what? Same as before. 1 mark for the tree. I'd give you a half mark for that. I'd give you a half mark for that. I'd give you 1 mark for the answer. Can you give yourself a lovely score, please, out of 27?